Give me the forces we looked at last time, if you know them.
Adhesion.
We looked at what?
Adhesion force.
Yes, Ruth, thank you very much. We have adhesion force. Pav?
Cohesion.
Cohesion force. Yes, Sean? Sean?
Yes, teacher.
Which forces did we look at last time?
Frictional force.
Friction force? Okay. Okay, I want you to see whether you are attentive. So there were those two forces, adhesion and cohesion. They are the forces that act in a body. Now, did you try out to this experiment about surface tension? Ruth, did you try out to the experiment about surface tension? Ruth? Members, I want
Yes,
to hear
teacher.
you. I don't want to see anyone who's muted or what. Paul, Catherine, please unmute. Unmute. I ask you answer. Did you try out to the experiment about surface tension? Yes? You didn't. Was it hard? Who tried out that experiment? No one. Ruben, did you try?
No.
No. Okay, that silence means no one tried, isn't it? Ah, you people. You are very, very unserious like that. At least you have tried out and then it doesn't come out. And then, but no one, did you try? Did you try? Members, did you try? What don't you have? You don't have water? You don't have a basin? Or you don't have a reservoir? Okay. Now I've seen you are not serious students. Some of you are not serious. Actually, most of you are not serious because you never tried out my what? My experiment. So you try out today and then you tell me. So well, let us look at capillarity. Now you know that we have trees. Do you know how trees absorb water from the roots to their leaves? Do you know how? Do you know how water keeps rising in plants? What if you soak a cloth and you put it in water and then you hold that cloth up? Do you know that after some time, the cloth will be wet? If you get a towel and put it in water and then you hold it upwards, but when the other part is touching water, is touching the water in the basin, do you know that after some time the towel will be wet, all of it?
Yes.
Do you know how paraffin rises in lamp wicks? So all that is done by what we call capillarity. By what? By
Capillarity.
So capillarity contributes to the rise and fall of some absorbent materials. For example, water, things that can be absorbed. For example, water can be absorbed. Paraffin can be absorbed. So the liquids rise up. The rise and fall of certain liquids or fluids in a given substance or material is what we call capillarity. So it is a tendency for a liquid in a capillary tube or absorbent material to rise or fall. So it must be a liquid that can be absorbed. And this liquid can do what? Can be absorbed and then it rises or it falls. That's what we call capillarity. So capillarity is all about the rising and falling of a liquid in a capillary tube or in an absorbent material. Absorbent material can be any material. For example, we have lamp wicks. Those lamp wicks can absorb water. So water can be easily absorbed in a lamp wick. So absorbent material can absorb something. For example, lamp wicks. For example, a towel can absorb water, can absorb. A blotting paper can absorb. So the tendency by which a liquid rises or falls in a capillary tube or absorbent material is what we call capillarity. It is a tendency. Is a what? Is a what? It is a tendency for a liquid to rise or fall. For a liquid, it is a tendency of a liquid to rise or fall in a capillary tube, or we can call it, or any material which is absorbent. What is an absorbent material? A material that can easily absorb liquids. A material, examples, let me put here, examples of absorbent materials. Examples of absorbent materials. Materials that can easily absorb liquids. We have wings. Inks. Dakia, do you know wings? Dakia?
No.
You don't know wings? In Tambi, they are called wings. Now you know what wings are. The one they use
Yes.
in stoves, in paraffin stoves. Those are wings. We have also a blotting paper. Blotting paper, we use it here in the laboratory. Out something. A blotting paper. We have a towel. Those small towels, when you put it in the water will rise in that towel. When you hang it, the water will fall down and the towel will become dry. So a towel or cloth. Some cotton clothing are absorbent materials. Are we together?
Yes.
So capillarity is caused by the two forces that we talked about. It's caused by the two forces that we talked about. The cohesion force, the adhesion force, and the surface tension. So there is the adhesion and the surface tension. Those two are all forces. They are all what? They are all forces. So capillarity is as a result of surface tension and adhesive what? Adhesive forces. Capillarity is as a result of these two forces, adhesion and surface tension. Okay. Why do we say adhesion? Why do we say adhesion? Why do we say adhesion? It is because adhesion causes liquids to rise in a capillary tube. Last time we were looking at why liquids have different meniscus. Let me first take you back. Why liquids have different meniscus here, like this. It is because instead of the liquid dropping down like the one for mercury, instead of water dropping down, instead it rises. It rises. This part has risen. Even this side it has risen, and down here it is flat, but this side it has risen, and here it has risen. Why? Because the adhesive forces are greater than the cohesion forces, and the cohesion and the adhesion force, the force between the molecules of water and glass, that force of attraction between those two molecules attracts the two forces and causes the liquid to rise along the glass tube. So adhesive force, it is the force that causes that rising of the liquid within the capillary what? Within the capillary tube. That is the adhesion force. So that's why I say it is due to the adhesive force. Now, what about surface tension? How is capillary action? How is capillarity or capillary action as a result of surface tension? So remember that we say that surface tension, it is a force that makes a free surface of a liquid to behave like a thin, stretched elastic skin or a thin membrane. So there is a membrane on water, and that's why we say that. That's why even insects can walk on what? Can walk on water, because there is a certain membrane on water. That membrane is caused by surface tension. So it means that surface tension, not that everything can walk on water. No. It depends on the level of surface tension on water. So surface tension, if it is high, then you expect objects to move on water. If surface tension is very high, then we expect low capillarity. But if surface tension is low, we expect high capillarity. Because there will be no membrane. There will be no membrane there on the surface of the water. That means that the water can be easily absorbed and it will rise. Whereas if the membrane, if surface tension is high, the membrane will reduce on the capillarity. So let us look at how do you understand, how can you study the capillarity in liquids? How can you study the capillarity in liquids? So you need these things. You need paraffin, you need kerosene, paraffin or kerosene, you need dry wink and a beaker. Dry wink and a beaker. Dakia, my dear, you are there, you don't know what a lamp wink is. Let me show you. Lamp wink. Dakia, you know? You have remembered?
Yes.
You know what a lamp wink is? These are lamp winks. These ones here. Okay? These are lamp winks. I think you can see them. Very many. These are lamp winks. Okay? So you have seen mommy doing this. Now there is an example here. So we need something like this. This is now a lamp. So the liquid rises through the lamp wink. What causes it is capillarity. Or the kerosene will rise and then you have fire. Or you have light. Something like that. So they are saying that now what do you need? You need a beaker and you need kerosene and you need a lamp wick. Let us see what they are telling us next. So they are saying that put kerosene in a dry beaker, then put one end of the wick in a beaker containing kerosene. What do you observe? Members. So let us go back in our books. Let us go back in our books here. And we are going to see, let us write investigating capillarity in what? In liquids. Let us write this demonstration investigating capillarity in liquids. We are going to write this demonstration. So we are going to write it from what is given to us. Are we together? From what is given to us. So the procedures are, let's write our procedures. Number 1. Pour kerosene in a clean what? Dry beaker. Then the next thing, dip one end of the wick in a beaker containing kerosene. Dip one end of the wick in a beaker containing kerosene. Containing what? Kerosene. Okay. So we are going to write. Instead of writing the question, what do you observe? For us, let us write observe. Observation. What is the observation? What do you observe? Now let me ask you. What do you observe? Sean.
Yes, teacher.
What will you observe? Should we first say
kerosene?
What do you observe? You observe kerosene.
Kerosene rising up on the wind.
Kerosene rising up. Okay, let us write that. Observation. Kerosene rises up. Rises up through the wick. Is that true? That is true, isn't it? Kerosene rises up through the wick. That's what we observe. What is your explanation? Explanation to the observation. What's the explanation to the observation? Why does kerosene rise up? Why does it rise up? Who knows?
I try.
Yes, Sean.
Kerosene rises up due to capillarity.
Due to capillarity. So is that enough? Where kerosene rises up due to capillarity. Kerosene rises up due to capillarity. Due to capillarity. Is that all? Which forces causes the liquid to rise up?
Adhesion forces.
The adhesion what? The adhesion force. So kerosene will rise up due to capillarity. And this is brought about, this is as a result of the adhesive force between the molecules of the kerosene and the molecules of the lamp wick or of the wick. And this is a result of the adhesive force between the kerosene, and the wick. More? molecules. That's why the kerosene will rise up. And it is a result of the adhesive force. Okay. Adhesive force causes liquids to rise up. So that's why it will rise within the lamp wick. Okay. So we have written the observation and we have given the explanation. We have given the procedure if you want to investigate. Pav. Do you have
Yes,
any
teacher.
question? Do you have any question, complement or subtraction or multiplication?
No, I'm okay with that.
You're okay with that?
Yes.
Okay, the next question we will go to Kathy. Kathy,
Yes.
Catherine.
Yes, sir.
Hey, there are two Catherine. Do we have Catherine here and Kathy? Okay, Kathy now. Kathy,
Yes.
do you know what adhesion is? What is adhesion?
I've forgotten.
Teacher,
Yes.
I have a question.
Yes, Pav.
It's not
First,
related
let
to
Kathy
this.
first answer my first. Wait, let Kathy first answer my.
Okay.
Kathy,
Yes, teacher.
what is adhesion? You said that you know, isn't it?
I forgot.
You have forgotten that you know. Okay. Adhesion is the force. Now, let me ask Dakia. Dakia, do you know adhesion?
It's a bit.
Adhesive force. What is adhesion?
Try.
Yes, you try.
Adhesion force is the force between the molecules that are greater than cohesion force.
Okay. Thank you. So adhesion force is the force in molecules of different substances. Kathy and Daki, have you heard? Molecules of different substances. For example, kerosene and the lamp wick. The wick and kerosene, those are different materials or substances. So they have different molecules. Their molecules are different. So the force between those two molecules, the force that may exist between those two molecules is what we call the adhesion force. The force of attraction between those two molecules of kerosene and the wick is what we call the adhesive force. So adhesive force is normally between molecules of different substances. For example, water and glass. The reason why water sticks on glass is because of the adhesive force of attraction between the glass molecules and the water molecules. Have you understood?
Yes.
Okay. Yes, Pav, what was your question?
The question was that when I logged in, it was something from app came and it told me allow free school to give you notifications about news and updates and those things. So is it necessary for us to allow that?
Yeah, you allow, because normally when we put in new videos, what you have a notification that there is a new video that has been uploaded, or there are new notes that have been uploaded. Okay.
Okay.
Yeah, it's okay. I've just configured it. It's me who configured it there. It's not it's not done by these terrorists. Okay, let us proceed and we look at liquids that rise in a capillary. Okay, or capillary rise in liquids, capillary rise of liquids in tubes. So we're going to look at capillaries of liquids in tubes. Okay, so we have this, that, and that. And right, capillary rise. Capillary rise of liquids in tubes. Okay, we are going to see how the liquid behaves if it is rising in a tube. How does it behave? That's what we are going to look at. So capillary rise and fall is due to the intermolecular forces in a liquid. Capillary rise and fall is due to the intermolecular forces in a liquid. Give me the name given to the intermolecular forces of a liquid. Which name is given to the intermolecular forces of a liquid? Now, Pav is there saying intermolecular forces. The name given to the intermolecular forces is what we call the cohesion force. Are we together?
Yes.
Hey, I want you to use this physics. I want you to understand this. That if you have liquids, if you have a substance, and there are molecules within that it's only water. These are only water molecules. So it means that the intermolecular forces between these molecules are what we call the cohesion force. Because cohesion is the force of attraction between molecules of the same substance, That means that it is the cohesion force. Yeah? It is the cohesion force that gives rise to intermolecular forces. Are we together?
Yes.
Yeah, so now they are saying that the capillary rise and fall is due to the intermolecular forces. We are going to say liquids that rise in a capillary tube. So we are going to look at the attraction. We have the attraction here, and we are going to look at the repulsion. The attraction and the repulsion. This is repulsion, and this is attraction. So let us start with the attraction part. So before that, we can say the rise and fall of a liquid to dark here.
Yes.
Make your young one keep quiet, okay?
Yes.
So part A, liquids that rise in a capillary, liquids that rise in a capillary tube, in brackets, attraction. Liquids that rise in, so some liquids rise in a capillary tube. Some liquids rise in a capillary tube. Let me see if there is some video here. Put your capillary rise. So these are quite long videos here, and I wanted something which is a bit short, not so long. Okay, let us maybe see this. It's going to take 6 minutes. We have 7 minutes. Of course, not Junior. My network here is
students, the purpose of this little experiment we're going to run is going to be to illustrate to you the
Can you hear what he's saying? Can you hear what he's
Yes.
saying? Yes?
Yes.
concept of capillary rise. So come and have a look at this setup. All right, so this is what you can see here. We have 3 cups, and in them all there is sponges, and their purpose is to prevent these columns from touching the bottom of the cup. So basically it's going to elevate the bottom of the cup. Okay, so we have 3 cups. We have 3 clear columns made out of simple plastic, and we have some fine sand. What I'm going to do is I'm going to fill up each cup with the fine sand.
So it's trying to fill up the cups with sand.
Next, I'm going to set up these clear columns in the cups.
Why does he put sand there? He just wants to see the color of that water.
And you will have noticed that the bottom of the tubes do not actually touch the bottom of the cup to allow for water flow.
I have to make it faster.
Now we are ready to put water in 2 of these cups.
So it's going to pour in water. You can see they are at the same level there. But it's going to pour in water, and you shall see how water will keep on rising. So the experiment can take quite a long time because the water rises very slowly and very slowly.
I am now going to move you in close so you can see what is happening to these tubes.
So it's just showing you that since the tubes were
Do you see how the
containing
water is rising in 2 of these
poured in
tubes where I
water,
placed water,
so it's
especially the
that,
one on the right?
showing you that the sand now becomes wet because the water is rising through it. So that's why at the depth here it is a bit
Whereas this
black,
tube,
and
no
here
water
this
was
one
placed,
doesn't have
obviously there
enough
is no water rising.
It did not pour there. But here you can see that here it is now rising. It is rising up, rising up, rising up. So the sand is becoming, let me say, more wet because the water is rising through it. Rising.
So if you will, consider the vessel on the left as the
That's what we
control.
call
You can see that the one on the right and in the middle,
rise
you actually have moisture
or
rising
to fall.
by virtue
So
of
this one is now
capillary
for
action
attraction.
through
Where
the
there is
column filled with
rising,
sand.
that's where we have attraction, and the liquid is rising upwards. So it
I'm
is
now going to
attracted
add
to
some more
rise
water,
where?
maybe to increase
Upwards.
the
So that's
column
why it
rise.
is becoming wet and wet here. Here the sand is becoming wet and wet. So the more you add in water, the more it will keep on rising up and up. So that's capillarity. Even if you have a lamp wick, the liquid will keep on rising. So inside the test tube, there was sand. And that's why it is now rising through the what? Through the sand, within the sand. So the moment you remove those if he removes those test tubes, you find that, or the capillary tubes, you find that the sand inside has more water. You see how it is rising up. It is rising up and up and up. So it is against the gravitational force, because gravitational force acts downwards, but now it is rising up. So that's how even the water rises in trees from the roots or from the ground, from the soil. It rises through the wood to the leaves, but through capillarity.
The final thing I want to illustrate is the surface tension in the water actually is able to maintain
So that's
some
the
strength in
experiment.
this
And then
soil.
when we come
So
back,
I'm going
we
to
are going to
let
write
this-
notes about this rising, and then we shall write
And look at
notes
this.
about
The
the
soil actually stays in the
falling
column.
of the liquid.
And that's because the surface
Back.
tension in the water is actually
So when this lesson
gripping
ends,
on the
please
soil.
join
If I were to pour
again
water now
and
through
have
the top,
the next session up to
I'd be made a
1
liar.
p.m.
But nonetheless.
Are we together?
Or if I were to apply some extra energy in the form of
Yes?
vibrations.
Yes.
Okay.
Monica, I just sent you the email with the client
Looking at the
notes.
doc now, but I think it's an older
Just
version.
ended.
You sent an updated?
Monica, check your messages when
So we can go back to our lesson.